So if we look at this, what we have is your list of possible rational roots are what we just talked about. All right? We talked about to make a list of possible rational roots, what we're going to do is we're going to take all the factors of the, what's this? Constant, and we're going to divide it by all the factors of the leading coefficient. And that gets us possible rational roots. So here, for right now, just make a division bar, and then we'll make a list of possible rational roots. All right? So on the top of this long bar, we're just going to make a really long bar like this, from here to here. All right? And remember that factors are both positive and negative, right? Because I could have positive 1 and negative 20, or I could have negative 1 and positive 20. To show that, I'm just going to put a plus minus up top and bottom. Plus or minus up top and bottom. And then we'll make our list when we're done. So on the top, what we're going to do on the top is we're going to list all the possible factors of our constant. What's our constant? Negative 20. 20 doesn't matter, right? So all the possible factors, starting from the smallest of 20. 1, comma, 2, comma, 4, comma,
5,
comma,
10,
comma,
20.
20. Cool. What's the leading coefficient?
1.
So what are all the factors of 1 on the bottom? 1. So within that, how many numbers are there if they're all positive and negative? How many total factors could there be? 6. Is that right? And then each one of them could be both positive or negative. So a total number of what? How many possible factors? 12 possible rational factors. That means there's 12 spots that are rational numbers that this factor, this polynomial, could have an x-intercept at. So let's go ahead and put possible rational roots. Possible rational roots. And since the denominator is 1, do we have to list it?
No.
No. So we've got positive negative 1, positive negative 2, positive negative 4. What's the next two? 5, positive negative 10, positive negative 20. And those are our possible rational roots. All right. So I'm going to show you how to use this little tool over here really soon. But for right now, we're going to test one. We're going to test one using division. All right. So let me ask you this. Let's test a 0 of 1. So come down here and put a 1 in that backwards L, and we'll list all our coefficients. Our coefficients are 1, 2, negative 19, negative 20. And this will be a root if I have what as a remainder? 0. This will be a root if I have 0 as a remainder. So let's see if it works. We drop it down, we get 1. We multiply and get 1. Add and we get 3. Multiply and get 3. Add and get negative 16. Multiply and get add and we get negative 36, right? All right. Is that a root?
No.
It's not a root because we don't have a remainder of 0. So I'm going to show you how to use this tool right here. This tool does the same thing. If you'll notice, I just listed some roots here. All right? And over here, I've listed all the, what are the numbers? Coefficients, right? All the coefficients are right there. And all you got to do is a little bit of it in your head, and this makes it much quicker. All right? So watch. I drop down the 1. It goes there. But now we got to do one thing in our head, right? 1 times 1 plus 2 is? 3. 1 times 3 plus negative 19 is? 1 times negative 16 plus negative 20 is? Negative 36. Cool. Did we get the same answer?
Yes.
Right? So let's test these quickly. And if we have to add more, we'll add more. All right? But let's test them quickly. So 2 times 1 is? I'm sorry, just a 1. Drop the 1 down. That's my fault. 2 times 1 is 2 plus 2? 4. 2 times 2 is 4. That's 4 right there. Yes, ma'am. 2 times 2 is 8. Sorry, 2 times 4 is 8 plus negative 19 is? 2 times negative 11, negative 22 plus negative 20? Negative 42. Is that a root? No, because if it was a root, we'd get what? 0. Let's go here. Drop the 1. 1 times 4 is 4 plus 2 is 6. 4 times 6 is 24 plus negative 19 is 5. Okay. 5 times 4 is 20 plus negative 20 is 0. Do we have a root? Yes. So we know a root, don't we? So one of our roots is 4. That means this. That means the actual factor is what? X minus 4. So let's go ahead and we're going to list our factors here. We know we've got a root of 4. So one of our factors, can you write factors underneath there? You're doing amazing. Thank you, thank you, thank you. So since the root is 4, our factor is x minus 4. And since it started off as a cubic, that is, so in parentheses, now next to it we'll put x squared plus 6x plus 5. All right? So right now, we've taken that cubic equation and we factored it into a first degree equation and a second degree equation. Let me ask you this. Does this factor further?
Yes.
Yeah, you're saying something multiplies to 5 and adds up to 6?
Yeah.
What multiplies to 5?
1,
1 and 5. So we're going to factor further. We're going to say x minus 4. And this factors into x what? X plus 1 and x plus 5. All right? So just now, you factored, so go ahead and write that as f of x in factored form. So here's what we did. Listen to the words, all right? We used the rational root theorem, all right, to factor x cubed plus 2x squared minus 19x minus 20 into x minus 4, x plus 1, and x plus 5. Now you've just factored your first higher degree polynomial, right, without being given a factor to start off with. Cool? All right. We hit, let's put that on there. Let's post that.